Okay, so in this video we're going to be writing functions from graphs. So it says determine a function that has the graph shown below. The horizontal axis represents angle measures in degrees. And then it says for an extra challenge write one cosine and one sine function. So for our purposes in this video we are just going to stick with sine because that's what we talked about in class today. But if you go onto the wiki space and check the answer key, there also is going to be some answers represented in cosine, which you should be able to do after tomorrow's lesson. So, recall that the equation for sine has 4 parameters. So, I'm going to use theta as my independent variable because the directions say that all the x-axis are in degrees, so I'm going to use just theta. But f of theta could equal, we could have a plus or minus in front of our a value, so remember that's just depending on if there's a reflection or not over the x-axis. Our a value is our vertical distortion, which we also call the amplitude of sine. And then we have our b value, which is our frequency or horizontal distortion, and we get our b value by taking 360 and dividing it by the period. And then that is multiplied by our independent variable theta minus our c value, which is just our horizontal shift left or right, or also known as our phase shift, plus our d value, which is our vertical shift up or down. So if we look at the first example, notice all these examples are calculator screenshots. It's important to be able to understand how to, look at these types of functions in your calculator because that's what you guys are going to be using as a resource. So if I look at the window, it says my window goes from 0 to 360 for my x min to max, and by a scale of 45. So that means that every one of these notches is 45 degrees. And then my y min max goes from negative 3.5 to 3.5, but it's going by 1, so that's a little misleading that this notch here is 1 and this notch here is 1. So it might be helpful to label those on the y-axis. Excuse me, sorry. Okay, so let's go through and just label some of our key points to help us here. Our first point would be 0, 0. And then if each one of these notches is 45 degrees, we could see that right here is 90, 1. And then 2 more over brings us to 180, 0. 2 more over brings us down to 270, negative 1. And 2 more over brings us to 360, 0. So you should recognize this right away as really it's just the parent sine function. Right? This is our 5 key points that we talked about in today's lesson. And how we can definitely just reassure that, if you look at our vertical distortion, which is just our a value, the distance from the center line up to the max or min is 1. Our vertical shift, there is no vertical shift because you look at our center line happens to be right on the x-axis. So our vertical shift would just be 0. Our phase shift, if we're starting at the point right on the origin at 0, 0, would be 0. And our frequency, which we can get by looking at one full rotation of the graph, which in this case is 360 degrees. So using my little formula up here, 360 over 360 gives us 1. So this ends up just being 1 times the sine of 1 times theta minus 0 plus 0, or f of theta is just sine of theta. So that's our parent sine function. So that's our most basic function for sine that we're going to use to talk about our transformations from this parent function. So that was number 1. That was just the parent function. Number 2, if we look at this, let's first identify what our window shows. So here the x min to max goes from 0 to 720 by a scale of 45. So each one of these, which you might want to go over with your pencil, is 45 degrees all the way till 720. And then our y min and max, it says it goes from 3.2 as a maximum, and the minimum is negative 3.5 by 1. So it's a little bit harder to see on here, but we have 1, 2, 3, 1, 2, negative 3. Okay? So maybe if we label a couple key points, going over 1, this would be 45, 0. Going over 2 more would bring us to 135, 3. So we're adding 90 to 45. If I add another 90 to 135, I'll bring me down to the x-axis again at 225, 0. If I go over another 90, that'll bring me down to this minimum value here at 315, -3. And if I go back another 90, that brings me 315 plus 90 is 405, 0. And I can continue if I would like. Up here would be 495, 3. And that's where we'll stop. So let's go through and identify all our transformations here, our parameters. So our vertical distortion, if we look at from our center line, which again we know is just at y equals 0, the distance from our center line up to that maximum point, or from the center line down to the minimum point, is a distance of 3. So our vertical distortion in this case is going to be 3. Our vertical shift, again, since our center line is right at y equals 0, is going to be 0. There's no vertical shift. Now our phase shift depends on what we decide to model as our sine function. So I'm going to skip that one for a second. We'll get back to it. Horizontal distortion, which is just our frequency, again, we're going to take 360 and we're going to divide it by the period. So remember, the period is just one full rotation of the graph. So if I start at 45, go through all 5 key points, that brings me to 405. And 405 minus 485 is just 360. So again, I get 1. I could have also went from 135 to 495, and 495 minus 135 is also 360. So for our phase shift, let's model one sine function right at 45 degrees. So I'm just going to say 45 right. And when I shift 45 to the right, notice from that point I am going up. So it's going to be a positive a value. So if I'm going to shift 45 to the right, my function would be 3 times the sine of 1 times theta is just going to be theta minus 45 plus 0. So I don't need to put that. So that's one way I can model it. I'll put that in green. Another way, just for more practice, let's say I choose to start from 225. Because again, I just need to make sure I pick a point on the center line. In that case, that would be 225 to the right. And if I choose to start at 225, notice I'm going down from that point. So my function, f of theta, I need to have a negative in front of my a value. So it would be -3 sine of theta minus 225. And really, I can keep going with this. If I wanted to model at 405, I can go a shift to the right 405 degrees, and I would just have a positive a value. Okay, example number 3. So here, again, let's use our window to help us understand what the scale is going by for our x and y axis. So it says that it's going from 0 to 720 by a scale of 45 degrees. So again, you might want to just go over with your pencil so that you could see all the different tick marks on the x-axis. And again, each one of these represents 45 degrees. So I'm going from 0 to 720 degrees. And then my y max and min goes from -3 to 3. So if we want to just label some key points that we could see here, going 2 tick marks over brings us to 90, 0. Adding another 90 to that brings me down to 180, and notice the y value is at -2. Going at 90 degrees more to the right, that brings me back to the x-axis at 270, 0. Another 90 to the right brings me up to 360, 2. And then if I go another 90 to the right, just to go through my 5th key point here, that brings me to 450, 0, because 360 plus 90 is 450. And I can continue if I'd like. Down here would be 540, -2. Up to here would be 630, 0. So let's start with our vertical distortion in relation to our center line. So remember, our center line again is just at 0, y equals 0. So there is no vertical shift. That would just be 0. Our vertical distortion, so if we look at the distance from our center line up to that maximum point, or from our center line down to the minimum point, is 2. Our horizontal distortion, our frequency, we need to highlight one full rotation. So I'm going to start at 90 and go through 5 key points. That brings me to 450. 450 minus 90 is also 360. So to calculate my frequency, 360 divided by 360 gives us 1. And then finally our phase shift depends on where we choose to start our sine function. So let's say I chose to start at 90 degrees to the right. So notice from that point I'm going down. So I need to make sure I have a flip over my x-axis. So in this case, going 90 to the right, I need a negative in front of my a value. In this case, my a value is 2. Sine of 1 times theta is still just theta. 90 to the right, I'm going to subtract 90 and then plus 0, so I don't need to put that. So that's one way that you can model this. The directions only say to model it one way, but just for extra practice, why don't we model from 270 degrees? So at 270 degrees, that's 270 to the right. Notice from that point we are going up, so there is no reflection needed. So in that case, f of theta would just be positive 2 sine of theta minus 270. And again, we can keep going as long as we're at a point on the center line. If we want to model from 450 degrees to the right, we would need a negative in front of our a value. And it would just be negative 2 sine theta minus 450. And finally, our last example here, let's look at our window. Again, it goes from 0 to 720 on the x-axis by a scale of 45. So I'm just going to darken the scale, the tick marks a little bit so I can see them. And then notice we have an extra line graphed here. That's just the center line, just to show you that the center line was shifted down. So I actually graphed the line y equals 1 so that you could see that. Our y-axis goes from -5 to 5, so each one of these represents 1 unit because the scale is going by 1. So that would be 1, 2, 3, -4, 1, 2, 3, +4. Okay, so let's label some points. Now we want to start 1 tick mark over. Let's start up here at a maximum. That's going to be at 45 degrees to the right, comma 2. If we go over our first point here on the center line, happens at 135 degrees because we're adding 90 from 45. It's kind of hard to see these tick marks, but that's 135 comma -1. If we add another 90 degrees, that brings us down to our relative minimum. That's going to happen at 225 comma -4. And then from there, if we go another 90, we're going to be back to our center line, which would be at 315 comma -1, because 225 plus 90 is 315. And then I can go back up another 90 degrees to the right, up to my relative maximum again. I'll be at 405 comma +2. And then maybe I'll just go one or two more points here. If I add another 90, that would bring me to 495 comma -1. And then finally another 90. 495 plus 90 is 585 comma -4. And especially on these types of graph, it's probably going to be beneficial for you to make sure that you label your axes. Okay? Or label the key points on the graph. Okay, so let's go through and see what we have here. So we have a center line that we notice is shifted down 1. So I'm going to label that here. We said that's y equals 1. That would be our vertical shift, would be down at -1 in this case. Our vertical distortion, notice from the center line up to the maximum, that's a distance of 1, 2, 3, or from our center line down to a minimum is a distance of 1, 2, 3. So in this case, our vertical distortion is 3. Our horizontal distortion, or frequency, remember we're just going to take 360 and divide it by the period. So in this case, if I highlight one sine wave going through 5 key points, that's 495 minus 135, which is actually just 360. So it ends up being 1 again. I could have also went from 315 all the way over to this point, and it would also be 360. So any point to point, as long as you're going through those 5 key points. So for our phase shift, let's first start by going 135 degrees to the right. Again, I just need to choose a point on the center line. So going 135 to the right, notice from that point I am going down, so I need a negative, I need a flip over my x-axis in front of my a value. So f of theta, again I'm using theta because the x-axis is measured in degrees, would be -3, since our a value is 3, sine of, our b value is still 1, so I don't need to put it, theta minus 135, and in this case I also need to subtract 1 because I shifted down 1 unit. Another way that you can model, if we want to show one more point, if I start at 315, I'm going up on the center line from that point, so there is no reflection. So in that case, if I go 315 to the right, that would just be represented by f of theta would equal +3 sine of theta minus 315.